Here's an SAT problem that says we've got a cube that has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube such that the sphere touches the center of each face of the cube. To the nearest cubic inch, what is the volume of the space in the cube that is not taken up by the sphere? So there's some space inside the cube that is not accounted for by the sphere. So it's basically going to be a difference of two volume calculations. We're going to find the volume of the cube using length times width times height. These images that you see over here are just taken straight off of the SAT reference sheet, so you don't have to have these memorized. You would just have to recognize when and how to use them. So length times width times height for the volume of the cube is going to give me 68 times 68 times 68, or 68 cubed. I'm going to subtract off the volume of the sphere, since my goal here is to find the volume that's inside the cube but outside the sphere. So I'm going to subtract off a 4/3 pi r cubed. I guess you'd have to watch out and make sure that they didn't specify a diameter for you here. So that's always something to be cautious of when you're doing calculations with circles, spheres, and cylinders. Make sure you are dealing with the radius and not the diameter. 34 is the radius. You can go to the calculator with that. I end up with 149,795.8 cubic inches. It says to the nearest cubic inch, so that 0.8 would round up to a 149,796 cubic inches.